Welcome back to Demo Town. I'm very excited today to present a live demo of the Advanced Renewable Power Mesh Power Grid, Infingrid. This sustainable, secure, distributed solution is a collaboration between the Indiana 5G Zone, Advanced Renewable Power, Performance Defense, and XQ. The Infingrid is a new generation of power solution that is built for extreme environments, like a desert or a cell phone tower on top of a mountain. Both sustainable and secure. It'll help prevent blackouts like we saw in Texas a few months ago, and also prevent ransomware attacks like the Colonial Pipeline, which deprived the East Coast of gas for so many weeks. So let's get directly into the demo itself today. So behind me, I have a mobile power grid unit. Imagine thousands of these connected. Now the mobile power grid can take input from 4 different types of energy. Solar, which we have simulated over here, wind, power generation like a diesel generator, and the existing grid network. So what it does is it brings it in and intelligently stores it within a battery for distribution. This provides security, it provides sustainability, it provides greater efficiency with power resources. Now within this industrial PC here, we see that there's volts, there's hertz, there's the entire network that we need to know that everything is healthy within our mobile power grid. Now this can live, as we said before, in a seaside resort in Africa or within a remote village in India. What's happening here is that information is then being transferred over to the CyberServer down here. The CyberServer is a product of Performance Defense. And this is an IoT gateway. And within it, which is great because it has an application space, that the XQ message gateway can live to encrypt the data before it's then sent over the 5G antenna. That from there, it goes to the cloud. And in the cloud, we have the Infingrid. The information that is stored there is then rehydrated or basically put back into a database and then visualized. And you can see how the Infingrid, which is a secure mobile solution, can manage thousands and thousands of these type of devices that can be placed across areas that are potentially will have environmental disasters. So very exciting stuff right here. And at the moment, I'd actually like to bring onto camera Dr. Nima from Advanced Renewable Power and Mike Johnson from Performance Defense, 2 of our collaborators in this. Okay. Hey guys, how are you doing today?
Good, how are you?
Thank you.
Great. Dr. Nima, let's start with you. Can you tell me what a mobile power grid is?
Mobile power grid is a renewable distributed power station, which basically is designed for communities, right? So we change the production of electricity and consumption of electricity from a concentrated area with fossil fuels to a renewable distributed. That's why we need the Infingrid in order to manage all the data distributed across. Let me just tell you why we have developed that, why we have developed the Infingrid and mobile power grid. 50 years ago, over half of the people in the world did not have telephone. Even if they had money, they could not have telephone. This was invented. The thing that is in my hand, it's called mobile phone. That solved the problem, and everybody today has phone and communication. Mobile power grid is exactly that is going to do for electricity. Right now, 1.6 billion people in the world currently do not have electricity, so they live in poverty, most in the southern hemisphere of the world, right? This is the solution for them. That's the development of the Infingrid.
So what's different about Infingrid? I understand there's cooling technology and something else that really makes this different than other mobile power grids that are out there.
Well, we don't know of any other mobile power grid which is out there or any Infingrid is out there. Yes, what is happening, generally speaking, even most on the energy, the mobile power grid, as you said very nicely, is made out of 4 major components. The production, which is again itself has 4 major components. The storage of energy, which is in batteries and all the energy storage system. The conversion of energy from one type and being able to get all the energy coming in at the same time, as you see it on the screen here, and then the Infingrid, it manages all the stuff together. Now, what's so special about this, in addition to all the stuff that we should be talking about, which is Infingrid, which is our core technology, is also thermal management system. Most batteries are designed really for the north of the world. We call it Northern Hemisphere, United States, Europe primarily. But if you go south in Africa, in India, in the Middle East, in South America, temperatures are very high. And temperature in batteries is 90% of the business. High temperature kill the batteries, and they don't last more than 1 or 2 years at most. We warranty these things almost 20 years. So we expect them to last forever. So we have lots of technology without getting into details of all the cooling system, all the heat exchangers, all the plenums and stuff like that. So there are a lot in the hardware area, as well as lots of them in the software area, the management of the Infingrid.
And so what do you think about this is really going to change the world? Like, why is this important?
Well, as I said, 1.6 billion people don't have electricity, so they don't have good healthcare. They don't have good water. They don't have basic necessities that they need to live. So Infingrid, we believe that mobile power grid with Infingrid will solve that problem and get them out of poverty. That's really our mission.
That's an amazing mission. That's great. Now on to Mike Johnson. Can you tell me a little bit about connectivity and monitoring in the CyberServer?
Yeah, no, thanks, Brian. Just to back up, we started with NTI and XQ and ARP working on this project, and just hearing from Nima and what this project does, it's just so exciting. I'm just so motivated by it. So just want to say thank you to everybody. Thank you to NTI. We've had just a great time working with you all. When we started with NTI, we wanted to build a 5G gateway for the lab. We wanted to have some solution that apps could be developed and could try out different things and work on projects like this and just have a really good time figuring out what 5G is all about and how we can bring it to the market. So I guess what I want to bring up is just two things, how we're coming to the table with our CyberServer, with connectivity and high performance computing. So first, high performance computing. What we didn't want is just to have a CyberServer that was just a gateway, right? We wanted to have the ability to have real-time data analytics, kind of high performance computing, things that are robust applications, trusted and certified, that can run on the device. So definitely wanted to have something where you could have machine learning and AI involved as well. So what we provide in the CyberServer is a quad-core processor. We have high-speed storage and high-speed memory, and we have an expansion capability. So that's one in terms of the computing aspect of it. In terms of the connectivity aspect of it, so we had a baseline 4G capability with our IP. When we got involved with NTI, we developed this unit within 3 months. So our team got to the table and said, how are we going to do 5G? And we were able to do that. We learned a ton on this. What this cyber kit provides apps developers is the ability to do wireless, wired, cellular, and what's also capable of Bluetooth and GNSS on this CyberServer development kit. So that's kind of how we're doing what we're doing in this CyberServer, Brian, for connectivity and monitoring.
What about cybersecurity? How does it help with that?
Yeah, a lot. So it's, he knows a lot about cybersecurity. XQ, that's their whole business. So it's been fun working with Brian and his team. When we developed the CyberServer, we carefully considered what kinds of cyber aspects we wanted to include in a hardware architecture. There's 4 aspects that we really thought about. And it starts first with the root of trust. So the root of trust is really about having known software, what's going to run in the box, and making sure that's the software that's actually executing. So how we do that is 2 things: secure boot and trusted platform module. So our unit has a trusted platform module built into the unit that does key management and kind of that security crypto processor capability. So those 2 pieces start with the baseline root of trust, and we ensure that our secure boot, when it launches, if the software is not signed the right way, it's not going to launch, it's not going to run. So that's part 1. Part 2, we have a trusted execution environment on this box. And so really that means we have 2 sides of an operating environment. One that's a rich OS that we have security enhanced Linux running on it. And the second is like an opt environment. So it's a secure world. So with the ARM Trust Zone capability in our processor, it allows us to separate specific hardware resources that we only want access to specific applications. So we can protect on the secure world on only specific hardware resources, specific applications that want to run. And then we have a rich OS that can run on the other side for more external applications. On top of that, as I mentioned earlier, is security enhanced Linux. So that provides us access control, a little bit additional level of security using that OS so for our application to have just that additional piece of security. The last piece is this CyberKit's a single board computer. We have the capability for expansion, as I had mentioned earlier. The expansion is enabled through a PCIe connection, and that will give you dissimilar processing. So for red-black architecture, you need to have dissimilar processing, and our CyberServer provides that.
I understand that it also helps with system updates.
Yeah, no, it does. So our background's avionics, and avionics, there's a data load capability. It's called ARP 615. So ARP 615 is a way to get data on and off. It's a standard protocol. So our company, we have a product. We have a product named our data loader. A data loader has three capabilities. One is a server capability, and a server really what it is it runs on a box and is able to load other units. A client is, and actually what we have on this box today is a client. So it will allow the box to be loaded remotely, wirelessly, over 5G or over wired or over Wi-Fi, for example. So that's the client. And then thirdly, we have a lab loader. So that could be something that runs on a desktop PC if it's local to the environment. It could run in the cloud, talks over the A615 protocol to load the box wirelessly there too. So we really provide that capability as well. And how that applies to the ARP is when there's lots of mobile Infingrids out there, we need the ability, so the connectivity to see those Infingrids on a dashboard, see how they're functioning, whether they need attention, and also the ability to load them in the field real time. So that's kind of what our box allows you to do with updates.
Great. Thanks, Mike. Appreciate it. It's been tremendous working with you both. We're so excited about what the Advanced Renewable Power Mobile Microgrid and Infingrid are going to be able to do. XQ's part in this is really, to provide perimeterless, zero trust, to get the data off of the device and bring it to the cloud. Sort of take what's in the database here, basically transform it into self-protecting data, bring it into the Infingrid, rehydrate the database that's there, and then have it pull into the Grafana dashboard there. And each individual packet is seeded with a quantum random number, and then the key is generated off of that. So it creates the resiliency against like state-sponsored attacks. But together, I think that we've come together to create a device that I think that through advanced renewable power is really going to like change the world and change the face of energy. And hopefully change a lot of people's lives as well. Thank you so much, everyone, today for your help, your attention, and sticking with us through a long day of demos and some exciting talks and about 5G and basically how the world's changing. Thank you again, guys. Did you have closing comments?
The data for the amount of data which comes to us from any of the mobile power grid to the data center or the command center is tremendous, hundreds of megabytes of information. We need that data to be secure.
Yes.
That's what you're doing. That's why you're doing the encryption. When we need that data to go through the 5G network with that stuff that you are doing for us. What do we need that data? We need to do the AI. We need to do data mining. We need to optimize the energy production, energy consumption, energy storage for the customers. So that's really another function of Infingrid that eventually we get into the system, and also the metering and all the stuff that we are doing in all digital.
That's a fantastic point. Thanks, Nima. We appreciate that. Thanks everyone for their time and attention today, and I'm glad that we were able to make this work. I'm going to pass it back to you, Junaid. Thank you very much.
Great. So another example of the kind of hands-on work we do at the Indiana 5G zone, real development. For those of you watching, hopefully one of the themes you can see is we're actually inventing systems, and inventing systems, not just for the sake of inventing or writing a paper, but actually doing the entire life cycle. So in the case of the energy system, as Dr. Nima talked about, how do you make a resilient energy system that helps people on a global basis, that's able to integrate, traditional systems of power generation, but also new like solar and wind, and make it smart and intelligent and cost effective and mobile all at the same time.